Okay, so welcome back. So last week we just revised very quickly what we were doing. We started looking at a topic on differentiation. As I mentioned earlier, this is an extremely important topic in basic science and engineering, mathematics, and so on, because a lot of things are changing in real life. You want to find out how fast it's changing, what is the maximum rate of change, and so on. So this is where the concept of differentiation come in. Okay, when you look at some of the practical problem given in the book towards the end, then you'll understand the application of this topic. So we started looking at limits and its relation to differentiation last week. And then what we learned is that, the concept of limit is given by this function here when x approaches a. And then what we do direct substitution. Direct substitution, if you find that if you get 0 divided by 0, we call this indeterminate. Okay, indeterminate. If it is not equal to 0, if it is not indeterminate, not equal to 0, then you can find the limit by direct substitution. Okay, if it is 0 over 0, this is where we need to either factorize or rationalize the numerator denominator. There are plenty of exercise given in your book. I want you all to try all the problems, as many as possible. If you cannot understand, just let me know. Okay, so I've given you some example as well, how to rationalize numerator or denominator. So today I'm going to take out another topic, okay, that deals with first derivative. Okay, please copy down first first derivative, first derivative of a function fx, and the function is given by fx using first principle. Okay, first derivative of a function fx using first principle. So this is another subtopic under the first section that deals with first derivative. But this is from first principle. What is the meaning of all this? Okay, so in section A, we will just recall what is the meaning of gradient, gradient of a line. I think most of you know about this. So just copy down gradient of a line. Okay, so gradient ialah kecerunan, gradient of a line. Whenever we talk about gradient, what we have in our mind is a line. So when you draw a line like this, it can be any line. Just draw a straight line. Okay, just draw a straight line like this. And assuming the equation of the line is given by y is equal to mx plus c. Okay, so we know from this equation, gradient is given by m. Okay, c will be the intercept on the y-axis, m is the gradient. So in order to find the gradient, you need to know 2 points. For example, point A, x1, y1. And then you need to know point B, x2, y2. Okay, so you need to know only 2 points because this is a straight line. And in order to find the gradient, very simple formula. So gradient is given by, gradient is equal to, gradient is given the symbol m. We give the symbol m. So gradient will be equal to y2 minus y1 divided by x2 minus x1. Okay, so that is the gradient. So this is a very quick revision, something that you already learned in Form 2. So what is y2 minus y1? So y2 is here, this point vertical height minus y1. So this will give you the vertical height. So if we draw one straight line from here to here, somewhere here, okay, and then a horizontal line here to here. These two lines made a 90-degree. So the vertical distance from here to here will be y2 minus y1. Okay, so the vertical height is y2 minus y1. Horizontal will be x2 minus x1. It is as simple as that. So basically, the meaning of gradient is you take the vertical height, divide by horizontal distance between 2 points, you'll get a gradient. For straight line, is very straightforward, very simple. What about a curve? Okay, so this is where we're going to look at derivative. So you need to understand how to find gradient of a curve. Gradient of a curve. Okay, so part A is gradient of a line, part B gradient of a curve. Okay, let's say you are given a curve like this. Now you are given a curve like this. Okay, and somebody asks you, what is the gradient of the curve? And someone asks you, what is the gradient of the curve? In fact, you cannot answer the question. Because the gradient is changing everywhere, the slope is changing. Basically, the meaning of gradient is a slope. If it is straight line, you notice that it has a single value for slope, right? It is same everywhere. But then if it is a curve, when you are here, the slope is less. When you're climbing a hill, I'm sure you all have done hill climbing. When you climb a hill, initially the slope is not so steep. And when you go higher and higher, it becomes steeper. It means the gradient is changing. So the gradient actually depends on the point where you are standing. So the gradient is depends on the point. So if you put a point A there, okay, and the gradient will be given by the gradient at point A will be given by the gradient of the tangent touching the curve at point A. So when you draw a tangent like this, okay, so the tangent touches that tangent touches the point A at a single point like this. Okay. So we are going to find what is the gradient of the tangent. So this will be the tangent. And this curve has a function y is equal to f of x. Okay, it can be any function. So what is the meaning of tangent? Tangent is a line that touches curve and only only one point. Okay, so a tangent to a curve is a line that touches the curve only at one point. It is touching at point A. So the gradient of the curve at point A, okay, is gradient of curve at point A is equal to gradient of tangent. Gradient of tangent to curve at that point. At that point, it can be point A or any point. Okay, so gradient, when we talk about a curve, the gradient is changing everywhere because this is a curve. So if you want to find the gradient, then you must ask back at which point. If somebody asks you, what is the gradient of the curve, then you must ask back at which point because the gradient keeps changing. So when you look at gradient at one particular point, like point A, the gradient will be given by the gradient of the tangent. So we must find where is the tangent. Okay. So it is given by the gradient of the tangent. So that is the concept. When we talk about gradient of straight line is quite easy to find. Gradient of tangent, it depends on the point. gradient of a curve depends on the point. So we look at part C, how we are going to use limits to find gradient of curve at a point. So that is part C. So we are going to use using limits to find gradient of curve at a point. Okay, so we are going to learn how to use limits. Okay, limit ialah had dalam bahasa Malaysia. Using limit to find gradient, keturunan of a curve at a particular point. Okay, so that is what we are going to learn. Okay, so what I want you all to do, I want you to draw a graph like this. Draw a graph like this first. Okay, and draw a horizontal axis. Okay, draw a horizontal axis and then draw a vertical axis. Okay, so I'm using color, you all can see more clearly. So here we're going to draw a function, a curve like this, a curve any direction like this, any curve. Okay, draw anywhere, any curve like this. Okay, now what we are going to do, now this one is supposed to be a vertical line, draw a vertical line, a proper vertical line, it doesn't look vertical. Yeah, move this. I think I'll erase this first, draw again, arrowhead. Okay, so what you do next, we label a point A here, a point A. We label a point A so that this point is located at a distance x. Okay, so this is located at distance x. I think I'll mute the, somebody's phone is on. Okay. Okay, so what that is what we have done. Just draw a graph and then label point A. And then this graph has a function, for example, y is equal to f of x. Okay, horizontal axis will be x, vertical axis will be y. So y is actually same as f of x. Another way of writing y. Okay, now once you've done this, when the horizontal value is equal to x, the corresponding vertical value will be equal to f of x. So you draw another dotted line here. So this value will be f of x. Okay, because the horizontal is x, vertical will be f of x. Okay. And then what you do, draw a straight line from A. Okay, I'll use colors, you all can see more clearly. So we draw a straight line from A until it touches another point on the same curve, maybe this point here. And then we label this point as B. Okay, label this point as B. And what is the x coordinate of B? So you draw a vertical line from B all the way until it touches the axis. And the distance from A, the horizontal distance from A to B, this distance is actually delta x. Okay, the distance delta x is actually here from here to here. Okay, so because A is located at x, B is located as x plus delta x. So this point will be x plus delta x. So delta x is a distance, it's a short distance, because what we're trying to do is we're trying to find what is the gradient at this point. Then we don't know where's a tangent, so we draw a line like this first. And that looks more or less like a tangent, but it's not really a tangent because your tangent will be somewhere here. Tangent supposed to be here. And so when you draw a line like this, the gradient of this line is approximately equal to the gradient of the tangent. Okay, so that is what we are doing here. So since this is x plus delta x, so this will be the x coordinate of B. So you'll notice that what will be the y coordinate of B when you draw a horizontal line here, also a dotted line. Okay, so because this is x plus delta x, so remember earlier when this was x, you get f of x. So when this is x plus delta x, here you'll get f of x plus delta x. Okay, so we get this value, f of x plus delta x, simply by substituting this inside this function. Now you'll get this. Okay, so what are we doing here? Actually, what we're doing is we want to find the gradient of line AB. So we draw a dotted line here, and then another dotted line here. This is 90-degree. Okay, so this point, the vertical distance is f of x plus delta x. This point is f of x. So this distance here will be this distance is known as delta y. We call it delta y will be f of x plus delta x minus f of x. Okay, so that is the vertical height. And then the horizontal distance is given by delta x. So this will be delta x. Okay. Now the gradient, what we're actually trying to do, we're trying to find the gradient at point A, but we know that the gradient at any point is the gradient of the tangent. So if you draw a tangent here, you'll notice that the gradient of the tangent is approximately same as the gradient of point AB, provided dx is small. So when you make dx smaller and smaller, then this line will come somewhere here. Now, for example, if you move point B to here, let's say this is B, this is B prime. Okay, this is B prime. And you move B closer to A, then the line joining A to B prime will be here. Will be this line. Okay, so this will be the line joining A to B prime. And then your dx is from here to here, dx will decrease. So when dx becomes smaller and smaller, then you'll notice that gradient of line AB will be approximately same as gradient of tangent through point A. Okay, when we make dx smaller. Okay, if it sounds complicated, don't worry about this. What we want to know is the gradient of curve. So here we write down gradient of curve at point A is approximately equal gradient of line AB. Okay. So gradient of curve at point A is approximately equal to gradient of line AB. In fact, line AB is here. And gradient of curve at point A will be the gradient of the tangent, which is here. Okay, so this is not exactly the same. So we put the approximate sign there. And this is approximately given by So the gradient is actually given by the ratio, the vertical height divided by horizontal distance. And vertical height is delta y. So this will be delta y divided by delta x. Okay, so that is a gradient directly from the figure. So as you bring point B closer to point A, your dx will become smaller. Dx is distance from here to here. So as you make dx smaller and smaller, then delta y by delta x, provided your delta x becomes smaller, then this will be equal to the gradient. So here we write when delta x approach 0, gradient at point A can be obtained from the gradient function. Gradient at point A can be obtained from the gradient function. Given by dy dx okay is equal to limit delta x approach 0 delta y by delta x. Okay, so there's something new you come across here. Maybe you all have never heard of this before. Gradient. What is gradient function? Okay. We have heard of function. Function is basically this. This is a function. Function is basically equation for a curve. Okay. Gradient function means when you differentiate this function, you find the dy dx value. Whatever function you get, that function is known as the gradient function. Because this gradient function will give you the gradient at any point x. And we call this gradient function. Okay. So what we are going to do here, you notice here we have delta y. Yeah? Delta y is actually equal to everything here. F of x plus delta x minus f of x. So we are going to replace delta y by that function. So this will give you equal to limit delta x approach 0, i.e. we copy down this dy dx again. Okay, limit delta x approach 0, so you got f x plus delta x minus f of x divided by delta x. Okay, so this is a very important formula for you to remember. Okay, so this formula means this is the first principle, dy dx from first principle. Okay, so when you're asked to find dy dx from first principle, remember this equation. Okay, in admits, actually you don't have to memorize anything because if you keep practicing, if you keep practicing a lot, then you'll find that all this equation will come automatically to you. Okay. So what we do in order to find the gradient, now this is a gradient function. Whatever you get from this equation will give you a function. It doesn't give you the gradient. So if you want to find the gradient, you substitute the value of x coordinate at that point. So what we do here, we substitute substitute x coordinate of A to find gradient at point A. Okay. So very briefly, yeah, we'll just go through the theory first. That's all for the theory. And the rest is all calculation. So we'll just revise very quickly. So we are going to use limits to find the gradient of a curve. But before that, we were looking at what is the meaning of gradient. Okay, in Form 2, you all have heard about gradient of a straight line. Whenever we talk about gradient, we think of a straight line. So gradient of straight line is very straightforward. It's given by y2 minus y1 divided by x2 minus x1. We need to know only the coordinates of 2 points for you to find gradient. But when someone asks you find the gradient of a curve, we know that gradient of the curve is not the same everywhere. It is changing. The slope is changing. Okay, so they must tell you at which point they want the gradient. And what is the meaning of gradient at any one particular point? Actually, we're looking at the gradient of a tangent at that point. Okay, it doesn't matter where is the point. So assuming this point A is given, if you draw a tangent, that will give you the gradient of the tangent will be the gradient of the curve at point A. So in order to find the gradient, this is where we use first principle. Okay, so here from the first principle, you got point A given by coordinate x. X value will be x, so y value will be f of x. And then when you go slightly further to the right, by delta x, this new coordinate of x will be x plus delta x. Substitute this inside this function, you'll get f of x plus delta x. So when you take this value minus this value and this value minus this value, that will give you delta y. Okay, so you take delta y divide by delta x, that will give you the gradient of this line. So this gradient is approximately same as the gradient of the tangent. Okay, here I've drawn the diagram exaggerated, but if you put b very close, then you'll find that it'll be very close. Then the gradient of the tangent and gradient of line AB will be very close. So the gradient will be exactly equal to dy by dx when delta x approach 0. And approach 0 means that it becomes smaller and smaller. Okay? So this is a very important formula, how to find dy dx when delta x approach 0. So I will solve a few problems for you, but I will give you one example first. Okay, just continue from there. Example. You asked to find dy by dx by using first principle. For the function so you are given a very simple function y is equal to 3x. Okay, so this function when they write like this, it means that f of x is equal to 3x. Okay, so that is the meaning. You're asked to find dy dx using the first principle. So remember the first principle, we are going to apply this. Okay, so dy dx, straight away we write dy dx. You asked to find dy dx, so we write dy dx. So dy dx is equal to limit delta x approach 0. Remember the formula, x plus delta x minus f of x divided by delta x. A very simple formula to memorize. From the diagram, we can memorize this. So what we do next, we are going to substitute 3x inside there. So copy down the limit here, delta x approach 0. Okay. Now remember that you are given, if you are given x, okay, then the function will be 3x. If x is equal to x plus delta x, we take everything here and substitute the x by this x plus delta x. So imagine that the place of x is taken by x plus delta x. Substitute everything there. So you'll get 3x plus delta x, okay, minus f of x will be 3x. It will remain like this. And then we divide everything by delta x. Okay. So what we are doing here, we're just substituting x by x plus delta x. Everything inside there. The 3 will remain there. And then this function is the same function here. Okay, it comes back here. Okay. And then the next part is just to expand the function. So you got limit delta x approach 0. So this will be 3x. Now we can multiply inside 3x plus 3 delta x minus 3x. Okay, divide by delta x. Okay, and you have 3x here. You got minus 3. These two can cancel off. And these two will cancel off. So you will get limit delta x approach 0. You'll get 3 delta x over delta x. So I'll just write it down here one more time. In fact, you can write your answer straight away. Okay. So whatever is here, just copy down here. And then we can see that even here, we can cancel delta x. Okay, so that will give you 3. That will be your answer. And you asked to find dy by dx using first principle. That is your answer. Okay, so we'll do a few exercise. Okay, based on this very simple concept, we will do some exercise first. I hope all of you have copied this. Okay, just revise very quickly. It looks very simple. We're just replacing x by x plus delta x here, then minus the same function, and then simplify, you'll get the answer. Okay, so I'm going to take you all back to the exercises. Okay, so exercise, we are going to do 2.2. Okay, so when you look at exercise 2.2, SE 2.2, question number 1. So I'm going to do question number 1F for you, and then probably 1H. So I'm going to do F and H. Okay, so there are so many other questions for you all to try. Okay, so the first thing, as I mentioned earlier, the best way to revise at maths. Okay, after you copy the answer, okay, don't look at the video, don't look at your book, go and try again. Try the same question again. Make sure you can get the answer. After you can do that, then you go back to 1, A, B, C, then you'll find that it becomes quite easy to do. So we are going to do question number 1. So copy down SE. So this is self-exercise 2.2. Okay, self-exercise 2.2, question number 1. Question number 1, we're going to do part F. So you are given the function y is equal to 2x cubed. Okay, you are given y is equal to 2x cubed. So what are you asked to find? You're asked to find dy by dx by using first principle. Okay, you are given this function. Okay. So y is also equal to f of x. So f of x is equal to 2x cubed, and that is given to you. Okay, so you write one more step, it becomes easy to understand. So f of x is equal to 2x cubed. Okay, so we are going to write the formula for dy by dx is equal to limit delta x approach 0 f of x plus delta x. Now is power of, sorry, before we write that, just copy down the formula first. F of x divided by delta x. Okay, so we just copy down the formula first. Okay, so now what we're going to do in the next line, we're going to find a function for x plus delta x. The function for x will be 2x cubed. So it means that in place of x, we're going to replace everything inside there. Okay, so this will be equal to limit delta x approach 0. So when you substitute inside there, you'll get 2x plus delta x cubed minus f of x will be 2x squared, 2x cubed. And then divide by delta x. Okay, so you got a cube function which you need to expand. Okay, so continue down there. So we're going to expand the cube function, which will be quite tedious, but we have to do this. Delta x approach 0. So in order to expand the cube function, I will do step by step. Once you are familiar, you can skip a few steps and do faster. So I'm going to take out step by step first. So you can write from here to x plus delta x square, and then you got x plus delta x, and then minus 2x cubed, the whole thing divided by delta x. Okay, so this part when you multiply together, it will give you back cube. Okay, so I put 2 here, 2 plus 1, now will give you back 3. Now we are going to expand this. Okay, so limit delta x approach 0. The 2 is still there. We are going to expand this. I'm sure you all know how to expand a square function here. So this will be given by x squared, and then take the 2 multiplied by the front part and the back part, and then delta x squared. So it will be given by x squared. Okay, so you'll get x squared plus 2x delta x plus delta x squared. Okay, so when you expand this function alone, you are going to get this. Okay, so easy way to remember how to expand a square function, you take the front part, square and put at the front, the back part, square, put at the back. The middle part is actually 2 multiplied by this times this. Okay, I'm sure you all know this. And then the x plus delta x is still there. So I continue at the bottom because not enough space. So this minus 2x cubed. And then the whole thing is divided by delta x. Okay. So it's quite tedious, but try to work it out step by step. If you have time, go through one more time again. So it's not finished yet. So we're going to put limit delta x approach 0. So now we are going to multiply inside there. This function going to multiply inside there. So it's quite tedious. So we take x squared multiplied by this, and then we take x squared multiplied by the term at the back here. And then repeat, and this part multiplied by the front, and then this part multiplied by the back. So the cube function make things a bit more complicated. But we have no choice. We have to expand like this. Okay, so we take 2 over there. So x squared multiplied by x will give you x cubed. Okay, and then the second term will be x squared multiplied by delta x. Okay, and then you'll get 2x squared delta x plus 2x delta x squared, and then plus x delta x squared plus delta x cubed, and then only minus 2x cubed, and then divide the whole thing by delta x. Okay, so copy first, then I'll explain. Okay, so what we are doing here, we are taking this value, x squared multiplied by x, you will get x cubed, x squared multiplied by delta x, you will get x squared delta x, and then 2x delta x multiplied by x will give you 2x squared delta x. Okay, and then 2x delta x multiplied by delta x will give you 2x delta x squared. And then the last term, delta x squared multiplied by x will give you x delta x, and then here you got delta x squared multiplied by this will give you delta x cubed. Okay. Now next what we're going to do, we are going to multiply the two inside. Okay, because you got bracket here, multiply inside. But before that, maybe you can simplify a bit first. You got x squared. Now look here, you got x squared delta x. And then here you got 2x squared delta x. So these two can be combined. So if you combine these two, I'll write in color, you all can see it. If you combine these two, this will give you 3x squared delta x. Okay, so we can just see from here x squared delta x plus 2x squared delta x. When you combine, this will give you 3x squared delta x. So when you multiply 2 inside here, what will happen? So this will be equal to limit delta x approach 0. Multiply the 2 inside there, you'll get 2x cubed, okay, plus 2 times 3 will give you 6x squared delta x, and then you'll get 6x delta x squared. Yeah, because here also you got one more term. You can see here 2x delta x squared and then x delta x squared. This also will give you 3. So 3 times 2 will give you 6. So you'll get 6x delta x squared. Okay, and then plus 2 delta x cubed. That's all. And then minus 2x cubed. And then this whole thing divided by delta x. Okay, so it looks a bit complicated, but try to do it step by step, and then you'll be able to understand. So from here, you'll notice that at the back here we have 2x cubed. This is 2x cubed, and here you got minus sign. So it means this part will cancel with this part. Okay. And then remember that at the bottom you got delta x. Okay, bawah, at the bottom you got delta x. So when you take this part here, 6x squared delta x divided by delta x, this delta x will cancel with this. So the front part you will have only 6x squared. So when you write there limit, sorry, when you write there limit delta x approach 0, okay, so you'll get 6x squared plus the second term will be 6x delta x. Then the last term will be 2 delta x squared. Okay, so this part here, 6x squared delta x, and this delta cancel with this delta will give you 6x squared. And then here 6x delta x squared, one of this can cancel with this. Now will give you only delta x. And then here you got delta x cubed. So divide by delta x will give you delta x squared. So we have already simplified until here. So what is the next line? In the next line, we are going to substitute delta x equal to 0 inside this function. So when you put delta x 0, you'll find that this part will be 0, this part also will be 0. Okay, so this is actually 0. This is also 0. Okay, so in the end, you'll have only 6x squared. That is your answer. Okay, it's so tedious. Actually, when you do dy dx directly from the question itself, we can find the answer. When you want to find dy dx, you just take the 3 here, multiply by 2 will give you 6x squared. As simple as that. But if you are using first principle, we have to go through all this process. Okay, go through all this process, end up with the same answer. Because the question is telling you use first principle, so you got no choice. You have to use this method. Okay, so this is the fundamental method. And so I've shown you how to do question number 1F. Okay, so question number 1F is here. I'll show you one more question how to do H, and then probably question number 3 as well. So we will look at this question. It looks very simple. Y is 1 over x. So question number 1H. Okay, so question number 1H. So you are given y is equal to 1 over x. And then you ask to find dy dx from first principle. Okay, so same thing, right? The function x first is equal to 1 over x. Write the function fx is 1 over x. Then remember the formula dy by dx. For first principle, always write limit first, delta x approach 0. So here you got x plus delta x minus f of x divided by delta x. Okay, and we have the function there 1 over x, we can substitute it. So you got limit delta x approach 0. So f of x plus delta x, we know that f of x is 1 over x. So f of x plus delta x will be 1 over x plus delta x, and that's all. So this will be 1 over x plus delta x minus 1 over x. And then the whole thing divided by delta x. Okay, so substitute directly. So when you simplify this, what we will get? Limit delta x approach 0. So here just fraction, just like the way you minus 2 fraction, you got a common denominator. So you take x multiply by here, x plus 1 multiply by here. And then you'll get the values. So here at the numerator, you get x minus x plus delta x. Okay, common denominator will be x plus delta x. Okay, so that will be the common denominator. And then at the bottom here, at the bottom you have divider. So when you divide by delta x, this is same as multiplied by 1 over delta x. Okay, so dividing by delta x is same as multiplying by 1 over delta x. Okay, and then we expand the function there, so you will get limit delta x approach 0. So here you'll get x minus, x will disappear. You got x minus delta x. So in the end, you'll have only delta x at the top there. And then at the bottom will remain the same. Okay, you can multiply the x inside there. You'll get x squared plus x delta x. Okay, so multiply by 1 over delta x. Okay, so we're just expanding. Expand the bracket, you'll get minus x. So x minus x will disappear. So you got minus of delta x, and minus delta x will remain there. So what we can do, you'll notice that this delta x and delta x can cancel. Actually, cancellation meaning that you are dividing by the same term. You'll get 1 and 1 there. Okay, so this will give you limit delta x approach 0. You'll get negative 1 over x squared plus the x delta x. Okay, so this is 1 over x squared plus x delta x. Okay, so this part cancel off. You have only 1 on top there, so negative 1. The bottom remain the same. So the next line, what we do, we substitute the x delta x equal to 0 inside here. So despite here will be delta x will be equal to 0. So when you put 0, immediately you'll get negative 1 over x squared. So that is your answer. Okay, so if you revise very quickly, you're asked to find dy by dx using first principle for this question. Rewrite something like this, so it's easier to see where is your x and 1 over x there. And then remember this formula. Okay, you have to remember this. And then whatever is inside this function here, take this and put inside there. So you got x plus delta x. The back part here is remain the same, minus, and then the rest is all simple mathematics. Just try to manipulate the function, fraction, and so on. So when you work it out until here, you'll get minus 1 over x squared. Okay, so I've given you the full answer for part A. Sorry, this is part F. Part F and part H. I want you all to try this again. Try this again on your own and see whether you can get this answer. If you cannot get that, refer back to your notes. Okay. So I will show you how to do one more question before we move on to next part. So this part is question number 3. By using first principle, find the gradient function. Now you ask to find what is the gradient function. Okay, in fact, the gradient function is your dy dx. Okay, so let's try part 3. You asked to find what is the gradient function. So copy down question number 3. Okay, so you are given y is equal to 3 plus x minus x squared. Okay, so 3 plus x minus x squared, just check again. Y is equal to 3 plus x minus x squared. So you are given this, you are asked to find what is a gradient function. Earlier I was talking about gradient function. So here you will learn how to find the gradient function. So what we do here, when you see this kind of question, always rewrite like this. It will be easier. 3 plus x minus x squared. So we know that the gradient function is given by the derivative, dy by dx, by the first derivative. So this is again equal to delta x approach 0, f of x plus delta x minus f of x divided by delta x. The same formula will appear again and again. So when you solve many problems, this formula will go into your head automatically. You cannot forget. That becomes your first derivative from first principle. Okay, so from here we just substitute everything there. So limit of fx inside there. So in place of x, tukar ganti with f plus delta x. So this will be equal to 3 limit delta x approach 0. So put inside there, you'll get 3 plus x plus delta x minus x plus delta x squared. Okay, so that is the front part. And then the back part, you'll have minus x squared minus f of x will be minus the same function, 3 plus x minus x squared. And then divide all this by delta x. Okay, so in place of x, for the front part, we replace it by x plus delta x. So this will be equal to limit delta x approach 0. So we just expand the function. So we get 3 plus x plus delta x minus, this part we need to expand. Because of the square here, because of the square, we need to kembangkan, you need to expand. So you'll get x squared plus 2x delta x plus delta x squared. And then minus, okay, minus 3 plus x minus x squared. Then divide everything by delta x and divide it by. Okay, so what we're doing, just copy down here. And then we square this part. Square this part. When you square, keep the bracket there. The next line, we're going to remove the bracket. We're going to remove all the bracket. And then we can simplify. So that is what we're going to do here. Limit delta x approach 0. So you'll get 3 plus x plus delta x. Remove the bracket, you get minus x squared. And then you got minus 2x delta x minus delta x squared. Okay, and then you got minus 3 minus x plus x squared. Everything divided by delta x. Okay, so there's a lot of writing. When you write a lot, your brain takes a lot of energy. Very fast you'll feel sleepy and tired. But please bear with me for the next few, probably another half an hour. Okay, after that it's just simplification. So you look carefully, you got 3 here, can cancel with this 3. And then you have x, this x cancel with this x. Then you got minus x squared cancel with this x squared. And then you got, what else you have? That's all, right? Then you can simplify. So this will be equal to limit delta x approach 0. Okay, so numerator we have delta x still there. And then you got minus 2x delta x minus delta x squared. Divide by delta x. Okay, so it becomes a bit simpler. Once you expand, you subtract, it becomes a bit easier. Okay, so this will be equal to limit delta x minus 0, delta x approach 0. So every term here, you are going to divide by delta x. Okay, the front term divide by delta x will give you 1. Here delta x will cancel. Here you'll get delta x squared divided by this will give you delta x. Okay, so you'll get 1 in front and then you got 2x, and then you got minus delta x. Okay, so the next step is just to ganti here. You take the 0, put inside here. So when you put the 0 inside there, this will be equal to 0. Okay, so you'll get 1 minus 2x. Therefore, gradient function is dx is equal to gradient function for the function given, f of x is given by 1 minus 2x. Okay, so this is from first principle. But if you differentiate directly, it becomes very simple from here. Easily you can see y is equal to dy dx will be equal to 1 minus 2x. You can get the answer in one line if you do directly. But here you are asked to use first principle. So we have no choice. We have to go through all this hassle, calculate like this until you get the same answer. Okay, so this part explaining to you the fundamental how to do this by first principle. Okay, so there are many questions given to you. So maybe I'll just try one question taken from formative exercise 2.1. Okay, so if you take a look at in your book, there are many exercises given to you. I want you to practice, keep practicing. Even 2.1, this is formative. It means it summarizes the first part, limits and so on. And then also on first principle. So I'm going to try 6 for you. So after looking at the answer, please go and read the question and try on your own first. Okay. So this will be exercise question number 6. Question number 6. So right here, formative exercise FE 2.1. Question number 6. Okay. So let's read and understand the question. Now, what is the question asking? The displacement of a squirrel running on a straight cable. Sometimes we see squirrels, they like to run on a cable, right? So the displacement means the distance. Distance, anjakan, that is displacement. The displacement of a squirrel running on a straight cable for t seconds is given by this value. Okay, so t is the time. So if you have a cable like this, for example, I just draw a cable there. And sometimes we see a lamp post. You got a lamp post like that, and then you got a wire coming here. Then you can see the squirrel running there. So maybe here there's a squirrel. So when the squirrel is running, the distance measured from the original point here, this will be your distance s. Okay, so when t is equal to 0, when you put t is equal to 0, when you see this equation, when you put t is equal to 0, then you get s is equal to 0, right? So that means that the squirrel is actually here, initial point, and then it's moving along here. Okay, so this t is more than equal to 0. You are given this function. So this s is actually your displacement, and displacement is given by s. By using first principle, find the velocity of the squirrel when t is equal to 5. So you're asked to find what is velocity. So velocity is actually v, given the symbol v. Okay. So you are given the function s, copy down the function first. S is t is equal to t square minus 3t. Okay, so this function is for displacement. You're asked to find velocity at one particular time, at how fast the squirrel is moving. So what is velocity? How is velocity related to distance, remember speed is equal to distance divided by time. So v is equal to v, which is a function of time. V is function of time is actually given by ds by dt, where s is also a function of time. Okay, so v is actually ds by dt. Yeah? If you don't want to write a t after the s is okay. It can be just ds by dt. So this value is equal to limit. Remember earlier we had delta x approach 0. Here there's no x there. So it must be delta t approach 0. And this will be delta s by delta t. Okay. So from first principle, this will be limit delta t approach 0. So here you will have s of t plus delta t minus s of t divided by delta t. Okay, so the rest is just substitution and then calculate based on the formula given to you. So in place of t, replace it by t plus delta t. So you still have this limit there, limit delta t approach 0. So substitute inside there, you'll get t plus delta t whole thing squared minus 3t, t now will be t plus delta t. Okay, minus st will be minus t cube, sorry, t square minus 3t divided by delta t. Okay, so what we are doing, just substitute and substitute everything inside there and simplify. Then the next line is to expand this function. Expand the function and remove the bracket. So we got limit delta t approach 0. So when you expand the function, you'll get t square plus 2t delta t plus delta t square. And then you got minus, remove the bracket, and you'll get minus 3t minus 3 delta t. And then you got minus t square plus 3t divided by delta t. Okay, so we're just expanding. Despite squaring, you get this function here. And then here multiply by the 3 inside and remove the bracket, you get minus 3 minus 3t. And then here minus t minus multiply by minus will give you plus. Okay, so the next is we look at the common terms here. Here you got t square. Here also got t square. It means we can subtract. We subtract this and this. And then you got minus 3t, and then you also got 3t here. We can subtract. Okay. And then you got 2t. So we can copy down. So you got limit of delta t to 0. So you got 2t delta t plus delta t squared minus 3 delta t and divide by delta t. Okay, so this will give you delta t approach 0. Okay, so you'll notice that here all these are divided by delta t, meaning that each of this term, you're going to divide by delta t. So the front term divided by delta t, this delta t cancel with this. Second term, you got square, so you'll have only one remaining. Third term, it will completely disappear. So when you simplify, you'll get 2t in front there. 2t in front there, and then you got delta t, and then you got minus 3. Okay, so the next line, we're going to substitute delta t 0. Okay, why? Because here delta t approaches 0. So when you simplify, you're going to get 2t minus 3. Okay, so what is 2t minus 3? And this is actually the velocity. The velocity vt. Velocity refer to how fast the squirrel is moving. Okay, therefore vt will be equal to 2t minus 3. And that is a function. That is a function which will give you velocity. And you're asked to find what is the velocity. What is the velocity when t is equal to 5 seconds? So what we do, we just substitute directly here. When t is equal to 5, the unit must be in second, 5 seconds. So v of 5 will be equal to 2 times 5 minus 3. Will give you 7 meter per second. Okay, I hope everyone can follow. If you don't use first principle, the derivation is very straightforward. And you are given this function, when you differentiate straight away, you'll get 2t minus 3. But here, unfortunately, you are asked to use first principle. So read the question very carefully and find out whether they ask you to use first principle or not. Okay, if they don't ask you to use first principle, you can directly differentiate. That is what we're going to look at the next part. The next part deals with direct differentiation. Okay, so this is a very short section on direct differentiation before we look at 2.3. Okay, so we just continue, go back to your notes. So I'll take you all back to the notes. Take you all back to the notes. So this is very short section. This deals with first derivative. So 2.2. Okay, the first derivative. Part A, you're going to look at first derivative for a simple function. First derivative for simple function. Simple function, like for example, y is equal to ax power of n. Okay, so if you are given a very simple function, how to find this first derivative? Okay, so if y is equal to ax power n, then dy by dx. So this is a rule you have to remember when you do differentiation. So what we do, we take this n, we write inside here, just behind the a. So you'll get a multiplied by n power of x n minus 1. Okay, it is as simple as that. Okay, or this can also be written like this, or it can be written like this, and d by dx you're asked to find derivative of this function. Okay, same thing, and the answer will be same, a n x power n minus 1. Okay, I'll just give you one very simple example. Maybe you all have learned this earlier. Very simple example. You're asked to differentiate the function with respect to x. This function, in bracket, you're given 5x cubed plus 3 over 4 x power 4. Okay, so whenever you got a plus sign like this, it means you can differentiate, consider this as two separate functions, and differentiate one by one. So for the first part, you'll get, you have a 3 there, bring the 3 behind the 5. Now you'll get 5 multiplied by 3 x to the power 3 minus 1. So here I write 3 minus 1, but actually you can write 2 straight away. 3 minus 1 plus 3 over 4 multiplied by 4. Power of x, 4 minus 1. So this will give you 5 times 3, 15. 15x squared plus the 4 will cancel. This will give you 3x to the power 3. Okay, that is your answer. Okay, I'll show you one or two more examples, and we still have about 10 minutes. Okay, and then you're given plenty of exercise. You can go back and try. So we are going to do self-exercise 2.3. Self-exercise 2.3. Okay, the notes are given earlier. And I will try question number 1, D and E. And then C, question number 3, C, and question number 4, B. So I'm going to do only selected question. Okay, the best way for you to learn is go back and try the same question again until you get the answer. Okay, after that, go and try all the other questions. Okay, when you keep practicing, you'll find that maths becomes very simple. Okay, so try to do that. Okay, so I'm going to do for you all the SE 2.3. So write down SE 2.3. Question number 1, D. Question number 1, D. 6 over square root. So you're asked to find the first derivative of the following function, meaning you asked to find this, and d by dx 6 over, this is a cube root of x. You asked to find this. Now whenever you do dy dx, okay, try to find the derivative. Whenever you see a square root sign, remove the square root sign first, express as a power fraction, fraction power. So this will be d by dx. So that is the first step. We put here 6 x to the power 1 over 3. Okay, because it's a cube root. So it's x power 1 over 3. And then anything that appears at the bottom here, bring it to the top. So the power will become negative. So you got d by dx. So this will be 6x to the power negative 1 over. Okay, so once you simplify or rearrange the equation, the next step becomes very simple. Direct differentiation. Okay, so this will give you 6 multiplied by negative 1 over 3. Okay, remember to put the bracket there because it's multiplication. 6 times negative 1 over 3, x to the power negative 1 over 3 minus 1. Okay, so this is 6 divided by 3 will give you 2. So in the front here, you've got negative 2. And Then here you got x to the power 3 times 1, 4. Minus 1 minus 3 will give you minus 4. This will be minus 4 over. Okay, so this will give you negative 2 over x to the power 4 over 3. Okay, so that is your answer. But if you want to write in a simpler form using the fraction, this will be negative 2 over, okay, cube root. Then because this is cube root, then so you got x to the power 4. Right? Here you got cube root function then. Okay, so you'll notice that it's not that complicated. The rule is that we try to remove the square root sign, replace it by fraction power, okay, and then bring everything to the top, becomes negative. Then the rest is simple. 6 multiplied by negative 1 over 3. Put a bracket there. So this one cancel with this, give you 2. So 2 times negative 1 will give you negative 2. And then simplify and then rewrite this again as a fraction. Why? Because the question give you in a root sign like this. The answer also will be in the root sign or in the third form. So that is question number 1D. Question number 1E. 1E, negative 12. Negative 12 cube root x squared 3. This is also very simple, but I'll just show you anyway. Yeah, y'all can try this or try the other questions later. So in question number E, you asked to find d by dx, negative 12 x squared cube root. Okay, so the first step is to remove the square root sign there. Okay, and then we write as a power fraction. This becomes 12 x to the power 2 over 3. Okay, x to the power 2 over 3. So this will be equal to, now we can differentiate directly. Yeah, you'll get negative 12. And then inside bracket, we put 2 over 3. And then x to the power 2 over 3 minus 1. Okay, so this one will cancel. When you divide by 3, will give you 1. Divide by 3 will give you 4. So 4 times 2 will give you 8. So you'll get negative 8 x to the power 2 over 3 minus 1. Remember all this fraction. Don't forget this. You studied this in primary school, maybe lower secondary school. Remember how to minus fraction. This will give you negative 1 over 3. Okay, so this will give you negative 8 over x to the power 1 over 3. So you can just rewrite this, simplify this like this. Negative 8 over cube root of x. Okay. So try this one more time. Try this one more time. It's not that difficult. You're also given question from A to C. Try all this first. So I'll take you to question number C. Same thing. Differentiate each of the following function with respect to x. Now you are given in terms of y. We're going to differentiate this function with respect to x. So I'm going to do this here once, but I want you all to try this again on your own. So question number 3. Question number 3. Question number 1. Question number 3. C. So you are given the function y is equal to 4x minus 1 multiplied by 1 minus x over square root of x. Okay, it looks very complicated. 4x minus 1, we got 4x minus 1 and then 1 minus x divided by square root of x. How to differentiate this? So what we do is simplify the equation first. Even before you differentiate, simplify this, expand the bracket first. So you got 4x minus multiplied by 1 will give you 4x We got minus 4x squared. 4x multiplied by negative x, you got minus 4x squared minus 1 plus x. Okay, divide by square root of x. So expand this. So here you got 4x, 4x in front, x at the back. Combine these two, will give you 5x minus 4x squared minus 1 divided by square root of x. Okay, so because it's divided by square root of x everywhere, so each of these terms is divided by square root of x. So this will be 5x divided by square root of x. So square root of x we write as x power half. Okay, write as x power half because it's much easier to differentiate. Minus, you got 4x squared divided by x power half minus 1 over x power half. Okay, and then the rest is all just simple mathematics. So you get 5x. This will be 1 minus half minus 4x squared minus half minus x power negative half. Okay, so remember at the bottom you got power half, right? So when you bring it on top, it becomes minus half. This x already have 1 there. Yeah, so 1 minus half. Here this is 2, 2 minus half, and so on. So when you simplify this, you'll get 5x power of half minus 4x power 2 times 2, 4 minus 1, 3. Yeah? So you'll get 3 over 2 minus x power negative. Okay. So from the first line, until here, we haven't done any differentiation yet. We're just simplifying the function. Make it suitable for differentiation. So the next part is where we find dy by dx. Therefore, dy by dx will be, now we can differentiate one by one. So this will be 5 half to the power x half minus 1 minus 4 multiplied by 3 over 2 x to the power 3 over 2 minus 1. Okay, and then minus negative half x to the power negative half minus 1. So when you simplify this, you'll get 5 over 2 x to the power negative half minus 6. Okay, 4 divided by 2 will give you 2 times 3 will give you 6. 6 to the power of x half minus negative will give you positive. So this will give you half x to the power minus 3 over 2. Okay, so the rest is just a rearrangement. So this will give you 5 over 2 square root of x. Okay, you'll get 5 over 2 square root of x minus 6 square root of x plus 1 over 2 square root of x cubed. Because it's 3 over 2, power of 3 over 2 at the bottom there will give you x cubed. So that is your answer. And dy by dx. Okay, so if you just revise this very quickly, so we have done question number 3C as well. So I've done D, E, and C. This is also very similar. Find dy by dx. Okay, all you have to do is differentiate first. I think I will do this in the video for next week recording. Then you all can see this how to do this. And then once you go through this, you're given two more problems to try. Okay. So my advice to you is try all these questions. Okay, the answer is given in the textbook. You can just flip and check whether you can get answer or not. Now, while you are doing, assuming you cannot get answer, try to think at which point you get stuck. For example, when you're doing this problem, okay, you want to simplify, maybe somewhere here you get stuck. You're not sure how to go from this step to this step. And then you'll notice that here you need to revise your basic mathematics. Okay, how to deal with power and so on. So you must observe your own understanding at which point you get stuck. If you need help, let me know. I can guide you so that you can recall. And some of you remember during the COVID time, I think many of you missed classes and so on. So you may have missed some very basic maths lessons. So you'll find that some of this factorization may be a bit complicated. So if you are having difficulty, let me know. So we can revise those topics first. So I want you to go through this again. Here, try as many questions as possible. And then we will continue next week. As I mentioned, next week I will do the recording. Then you can watch the recording. So I'll stop the recording here.